everyone, we are going to continue our topic of proofs today, and what I want you guys to do is try this first warm-up problem on your own. So go ahead and attempt the problem and then check your work afterwards. So go ahead and hit pause right now. Thank you. Okay, welcome back. Here's what we should have gotten for our proof, so go ahead and take a moment and read through it. There was another way you could have approached this problem. You could have gone about and said that angle E is equal to 90 degrees, because if an angle is a right angle, then it's 90 degrees, and then gone ahead and stated your final statement, that is, if angles have the same measure, then they are congruent. Okay. All right, I'm going to go ahead and do the next example with you guys. So it says ray BG bisects segment AC. So we're going to go ahead and write that down as they're given. And I'm going to go ahead and draw that in so I know where BG is also. So BG, now notice that the ray is on G, so this continues. Okay. Then we say that E is on BG, ray BG, and that E is between A and C. And we can assume that from the diagram. Okay, remember that you are allowed to assume between this, and we can see that point E is on ray BG. Okay. So since we have a ray, remember, and it says it bisects, remember that it bisects it into two congruent parts. So that means that AE is congruent to EC. So we're going to say AE is congruent to EC. And remember those definitions that we talked about that you guys need to know from the previous slide. Okay. And we state that if a ray bisects a segment, and make sure you guys use the right piece. So in this example, it said a ray bisected the segment. If it was a segment, then you make sure you say a segment in your definition part for your reason. Then it divides a segment into two congruent parts. Okay. And then finally, since we have two congruent parts, we know that point E is the midpoint. And the reason being would come from the notes from yesterday. If a point divides a segment into two congruent parts, then it is a midpoint. Okay, again, I cannot stress to you guys enough the information from yesterday, or I should say the previous video. All right, so let's get into today's topic. Today's topic is going to be perpendicularity. Okay, first of all, what does it mean to be perpendicular? So if lines, rays, or segments that intersect at a right angle, they are considered perpendicular. Okay, and we use this little upside down T symbol to represent perpendicularity. So here are some more of those definitions that you guys need to know. So we're going to take those if-then statements from the definition. So if two lines, rays, or segments are perpendicular, then they form a right angle. And if two lines, rays, or segments intersect at a right angle, then they are perpendicular. Okay, and then two more definitions. If lines form right angles, then the lines are perpendicular.
If lines are perpendicular, then the lines form right angles, which is kind of basically what we just said. All right, so the first thing we're going to do is just actually practice what we can prove, okay, and practice some math, like arithmetic with this stuff. So it says line EH, which is this line right here, is perpendicular to HG. So that means then that angle GHE is a right angle. We can't say, even though it looks like it, we can't say that's a right angle because we don't know about bisecting or perpendicularity. Okay. All right, let's look at example 2. Example 2 says ray AB is perpendicular to ray BC, which means this is a 90-degree angle. 90-degree angle means it adds up to 90 degrees. Angle ABD is 4 times larger than DBC. So remember, any type of these types of problems, we want ratios. So this is 4x. Make sure we include the variables. So 4x plus x equals 90. 5x equals 90. So x equals 18. Remember that this is not my final answer. I still need to plug it back in and find the measure of angle ABD. So 4 times 18 equals 72 degrees. Okay, remember quite a few of us did this on Class Kick, so make sure that we are answering the final question. Okay. All right, then the next example asks, is ray AB perpendicular to ray BC, given that the following angles are 43.79 and 47.21. Okay, in order for it to be perpendicular, it needs to be 90 degrees. And this should say angle 2 there, sorry. This actually equals 91 degrees. So no, doesn't equal 90 degrees. Okay, all right. So let's go ahead. We have one more mathematical problem, and then we have 2 more proofs. Okay, so it says, given 1, 2, and 3 are the ratio of 3 to 1 in that order. So 3x, 2x, 1x. Remember that anytime you're given the ratios, you want to plug in x's. Okay, and the measure of angle 4 is 66 degrees. Determine if segment ST is perpendicular to segment PQ. So first, notice that all 4 angles make a straight line, a straight angle. A straight angle adds up to 180 degrees. So we're going to take all 4 angles and add them up to 180 degrees. So we have 6x to equal 114, x equals 19. That's not my final answer. I need to figure out if they're perpendicular and what's the measure of angle 2? Careful, that part was written right here. So the measure of angle 2 is 38 degrees. 1x is just going to be 19. And then 3x is 57. So are those 2 segments perpendicular? And the answer would be no, due to the fact that we don't have right angles. So no, ST isn't perpendicular to segment PQ because we don't have right angles. Okay, so in order for them to be perpendicular, you would need to have a right angle, which means 90 degrees. Okay, let's go on to the proofs now. We have 2 proofs to tackle. So given is AB is perpendicular to segment BC. So let's go ahead and mark that on our diagram. And DC is perpendicular to BC. Again, remember that the only time you can mark things on here is items that are given to you. Okay? Well, if two segments are perpendicular, then we know they form right angles. So we know that angle B is a right angle. Because if two segments are perpendicular, then they form a right angle. Okay, and that's just using the definitions from the previous page. Well, that can also be said true about angle C. And we don't need to write this all out again. We can just say same as number 2. All right, so now we know that angle B and angle C is a right angle. Well, using a definition from our 2.1 video, what do we know about right angles? Right angles are congruent. So if angles are right angles, then they are congruent. And we proved our statement. So biggest thing is do not assume anything, right? Remember, pretend like I know nothing. And you have to create basically, I like to think of it as like a storyline. Okay, how to get from point A to point B. All right, let's go to the last slide for the last example. Okay, and this is going to be our most involved one. So first of all, let's mark our givens. So BD, ray BD bisects angle ABC, and measure of angle CBD is 45 degrees. Okay, so BD, ray BD bisects ABC. Okay, and we know that CBD is 45 degrees. Prove that AB is perpendicular to BC. Well, first of all, we can say that angle DBA equals 45 degrees. And we can say that because if a ray bisects an angle, then it divides it into two congruent parts. So now I can go ahead and mark my diagram that this is 45 degrees because I proved it. Okay. Well, we see that both of those angles are 45 degrees. So if we add them up together, angle ABC equals 90 degrees by the angle addition postulate. And what do we know about right angles? I just said the answer. Hey, when I do that. What do we know about 90 degrees? They form a right angle. So angle ABC is a right angle. And we can say that because if an angle's measure is 90 degrees, then it is a right angle. And then using today's information, we can finally conclude that segment AB is perpendicular to segment BC because if two segments form a right angle, then they are perpendicular. Or intersect, I should say intersect. At a right angle. Then they are perpendicular. Okay, so that concludes today's video about perpendicularity. Basically, all we did was add on 2 more definitions that we need to know for our proofs. Again, start from point A, get to point B, assume that I know nothing, okay? And that you have to basically walk the story for me. Thank you guys so much for listening to my beautiful voice, and I hope you have a wonderful day.